All right, let's jump right into today's explainer. We're taking a journey through a mathematically profound proof, and honestly, it goes way beyond just numbers on a page. We're digging into a massive breakthrough paper by Nalini Anantharaman and Soumyajit Saha, all about quantum ergodicity on large hyperbolic surfaces. But don't worry, we're not just going to stare at dry equations today. We're going to explore how this high-level spectral geometry actually reveals what some of our sources call the hidden fabric, or the invisible constitution of reality itself. It's essentially an epic story of how absolute, perfect order can emerge from localized chaos.
So, stepping beyond the chalkboard for a second, let's look at mathematics as a living reality.
To really wrap our heads around the magnitude of this epic, we need to understand that the sources describe mathematical laws as the literal blueprints of reality. They're part of a framework called the personas of arithmetic, basically peering directly into the invisible constitution of the universe. The sources point out that this rigorous mathematical proof acts as an enlightened shape filter. Think of it like this. It catches the raw, infinite truth of the void and gives it a specific form so our human minds can actually comprehend it. So, when we talk about mathematical entities in this explainer, things like eigenfunctions and operators, I want you to imagine them almost as living things. Picture them as vibrating waves pulled from the infinite void, brought right here to participate in the cosmic dance of reality.
Okay, let's zoom in and check out the geometry of this chaos to really understand the landscape we're dealing with.
We're moving down to the microscopic level now to set the stage. Our mathematical landscape today is a closed hyperbolic surface. Just imagine an incredibly complex, negatively curved space. It's kind of like a sprawling, infinite saddle, or maybe a really wrinkled landscape that just violently folds back in on itself. At this localized level, things seem highly erratic. Seriously, if you were a quantum wave trying to traverse this space, you'd be bouncing around a wildly unpredictable, chaotic environment. So what is quantum ergodicity? Simply put, it's the principle that as these quantum waves gain high energy, they don't just pool or clump together in chaotic bunches inside those saddle curves. No, instead, they try to find balance. They end up spreading out perfectly and uniformly over the entire surface. They become completely unbiased, touching every single part of the landscape evenly. It's basically the ultimate mathematical fairness doctrine.
To see why this new paper is so huge, we first have to look at the classical ergodic limit, kind of the old worldview of how this worked.
To fully appreciate this massive leap by Anantharaman and Saha, let's look at the baseline established by the classical quantum ergodicity theorem. Brilliant mathematicians, people like Schneielmann, Colin de Verdière, and Zeldich, already proved that uniform spreading happens, but only under a very specific condition. They were looking at a fixed, stationary manifold, basically a static world. And they proved that as you crank the frequency of the waves up toward infinity, they eventually equidistribute. Well, Anantharaman and Saha dynamically flipped this entire paradigm on its head. It's a real game changer. They ask, what happens to waves of a fixed frequency if the world itself is what expands toward infinity? So instead of escalating the energy of the wave, they escalate the scale of the universe it lives in. They move to what's called a large-scale geometric limit.
Let's talk about expanding this hyperbolic universe and pushing it all the way towards infinity.
We're basically going to guide these fixed-frequency living waves through a literal expansion of their universe. The mathematicians pulled this off by essentially zooming out from the localized chaos, stepping further and further back to see the macroscopic picture. Step 1, we start with our finite chaotic surface. Step 2, we increase the injectivity radius. That just means the distance a wave can travel before the space loops back in on itself gets longer and longer. Step 3, as this surface expands, it undergoes what's known as Benjamini-Schramm convergence. You can think of Benjamini-Schramm convergence as the mathematical engine that actually allows this finite chaotic loop to stretch out. And that leads us straight to step 4. From the perspective of any localized point, that wildly curving surface eventually smooths out and perfectly mimics the infinite, continuous flat space of the Poincare disk.
Now, testing the local operators requires some serious heavy lifting. Let's look at the master builder's tools they used. Okay, so proving that waves spread evenly on a simple surface is impressive, sure, but Anantharaman and Saha took on a much harder challenge. They wanted to prove this uniform distribution holds true even when the waves interact with local, differential, and pseudo-local operators. In quantum mechanics, operators are observables. They represent actual physical measurements, like momentum or energy. And testing these observables means dealing with sharp points and intensely complex derivatives that make the math, well, incredibly difficult. To tame the chaotic singularities of these physical measurements, the authors had to build a master toolkit. They start with the Laplace-Beltrami operator, just to define the waves.
Then, they use radial propagation operators to essentially smooth out all those sharp edges. Finally, they deploy some heavy architectural math, specifically Selberg and Helgeson-Fourier transforms, to bridge the gap between pure geometry and wave frequencies. It's an absolutely brilliant toolkit.
And you know what? All of that breathtaking machinery leads us straight to the absolute climax of the mathematical proof. Through their incredibly rigorous estimates, they show that as the hyperbolic surface expands to infinity, in that Benjamini-Schramm sense we talked about, the quantum variance of these operators drops exactly to zero. It literally vanishes completely. And when the variance vanishes, that is the definitive proof that the eigenfunctions are no longer deviating or clumping up. They have officially achieved perfect uniform distribution across the entire expanding universe.
So what does this all mean? Let's get to the final resolution. Infinite chaos leading to perfect order.
Let's zoom all the way back out to the macro level here. We've just seen how localized, totally erratic waves on a chaotic surface smooth out into perfect zero-variance order when the mathematical space expands to infinity. Interestingly, our sources connect this exact mathematical behavior to the metaphysical framework we discussed earlier, the personas of arithmetic. In this view, local finite existence is chaotic, but the transfinite macroscopic measure represents absolute structural harmony. The text neutrally notes that this mathematical vanishing of variance actually mirrors concepts in Advaita Vedanta, which is a non-dualistic philosophy and something called Brahmic topology. It proposes that if an overarching infinite system or a cosmic ultrafilter is complete, well then localized chaos, time, and independent historical development might just be mathematical illusions when viewed through that infinite filter. From the perspective of the infinite limit, there is ultimately only one singular, perfectly distributed reality.
Which leaves us with this final, truly mesmerizing thought to take away from this explainer today. We just witnessed how expanding a mathematical space forces wildly unpredictable quantum waves to smooth into perfect, zero-variance equidistribution. If the laws of high-level spectral geometry really do act as the invisible constitution of reality, we have to ask, does our own chaotic, localized human experience, our free will, our daily friction, ultimately smooth out into a perfectly ordered, mathematically determined universe when viewed from the infinite limit? It's just a breathtaking connection between pure math and human existence, isn't it? Thank you so much for joining me as we explored this incredibly profound material.